Hello, welcome to the Wolfram Technology Conference. Today's talk is the visualization overview. My name is Brett Champion, and I'm the manager for the visualization team here at Wolfram. And we have a lot of things to cover today, so we will jump right in. Just go ahead and get started. And I'm going to cover questions at the end of the talk so I can get through as much of my material as possible. So we're going to be looking at what's new in visualization in the Wolfram language from version 12.2 through the upcoming version 13. And I'm going to do it a little bit out of order. I'm going to start with version 12.3 material, then do the version 13 material, and then come back around to show off what was new in 12.2 as time allows. I'm not going to cover everything, and in particular, the things that I'm not going to spend a lot of time talking about are things that are covered by other talks, mostly today. So vector field visualizations by Timothy McDevitt is immediately following this talk. Geographic visualizations is at 11 a.m. Central Time by Nirmal Malapaka. At 1 o'clock this afternoon, Min is going to be talking about axes and scales. And at 2 o'clock today, there's a general office hours for visualization and graphics, and we'll have a whole bunch of team members there available to answer questions without having any specific material pre-planned for it. So bring your questions and we'll have a good discussion. And then finally, there's several talks that are just general graphics related types of things. So tomorrow, James Lane is going to be talking about various graphics improvements, and I think some of the axis object stuff that maybe Min doesn't get to in his talk today. Alex Schittelbauer is going to be talking Friday about some of the about photo-based rendering, physical-based rendering. So material shading and some of the additions that we've done in the last couple of versions along those lines. And then at noon tomorrow, or noon on Friday, Yutsu Lu is going to be talking about writing GSL shaders in the Wolfram language. So moving on to what's new in 12.3, we're going to look at list line plot 3D, which is a new function to fill in the gap between list point plot 3D and list plot 3D to give us a curve generator coming from data. And there's two different types of data that it can take, really, and it does different things with them. So the first case that we're going to look at is the case where you're giving it a bunch of XYZ triples. And in that case, it's going to behave similar to what list line plot in 2D would do with that, and just draw a line connecting all the points in the order that you gave them. So here I have a spiral type shape in 3D, and I've got something times cosine of t, something times sine of t, and then I've added a vertical component as well, and t's going from 0 to 20 in kind of small steps. And so we get a curve that starts at the middle and spirals its way out and up. And another possible use for this is to visualize various forms of random walks. In this case, we have data that's coming from angle path 3D with random directions that you're taking each step size. And here we have 4 such paths, 3 such paths. And they go off in different directions. And to be honest, these are my favorite random walks visually that I've seen in quite a while. It's like you've taken a spring and just stretched it out so that it got uncoiled in some weird way. The other form of data that list line plot 3D can take is not when you're not giving it XYZ triples, but you're just giving it sets of heights. So this might be a regular grid, or it might be a little bit irregular, but as an example for this, we've got 0, 1, 1, 1, 1, and then a bunch of 2s, and then a bunch of 3s, and then some 4s and 5s. And what listline plot 3D does in this case is it creates what's sometimes called a ridgeline plot. And so it's drawing one line through each of these sets of heights. And so we have 0 and then a bunch of 1s. And then we go on to our next style even and get all the 2s, all the 3s, and then our 4s and our 5s. And this can, here's an example that I was playing with that uses this. And I wasn't originally writing this example with listline plot 3D in mind, but it occurred to me that it might look kind of interesting. And so here we have the amount of daylight at different places on the Earth. And so each of these lines, so the x-axis here is a year measured out in 1 week intervals. And so this is January 1st, this is December 31st, and we have a point, every week along that. And the axis going the other way is corresponding to what latitude you're at. So this is, I think, -80, -60, 40, 20, etc. And so we can see, sort of at your extreme latitudes, you have those periods where it's dark for 24 hours a day, or sorry, I guess this would be sunlight for 24 hours a day, dark for 24 hours a day, and you have the symmetry. So when it's dark at the South Pole, it's light at the North Pole, etc. And then you can sort of see how much variation you get over the course of the year at different latitudes. And this point here, I think there's some glitch in the logic of how I'm calculating how much daylight there is, because that corresponds to a point where sunrise was at midnight in that location. And so it's getting, it's, I think, basically off by a day one way or the other in my calculation there. The calculation is hidden in this iconized cell, but it takes up about as much space as this, and is kind of messy and complicated, handling the different cases of what happens when starting from midnight, you have sunset and then sunrise later in the day, because how weird things happen sometimes. Here's another application using time series. And so we have the stocks, Apple, Amazon, IBM, and Microsoft, and we're looking at the cumulative fractional change over, for starting at the beginning of last year and ending at the end of last year. And here we have, you can sort of see and compare. Everybody took a bit of a dip in March for some reason. And then eventually the stock prices started to recover as people got more accustomed to what was going on in society at that point. So now we'll look at, actually, I want to mention one thing real quick about that. So, because there's a small 13 feature in here that I think Min will discuss more in his axes and scales talk, which is that in this case, we have time series, and in 13, a lot of the visualization functions, including listline plot 3D, are able to see the time series and generate the date axis directly, instead of having to go through without us having to introduce, say, a date listline plot 3D function. So he'll talk more about that. One of the other features in version 13 is the addition of plotting over infinite ranges. And I know Stephen showed an example in his keynote yesterday, and I wanted a slightly more interesting example. So I concocted this function, which is a little bit exotic, and if you do the plot, it's a little bit hard to see what the long-term behavior of it is. So here we're plotting out to 100, and it's getting smaller, but it's still oscillating. Go out to 1,000, it's still maybe a little bit smaller, still oscillating a lot. So let's just go ahead and plot it out to infinity off to the right. And I mean, we don't see it get down actually to 0, but we see that it's maintaining that downwards, that it's, the magnitude of the oscillations of the function is decreasing, sort of as we go off further and further to the right. And if we check, then the limit, in fact, is 0, and it eventually does get down to 0. And so this is still using numeric sampling of the function. So there are some limitations to how the infinite domain plotting will work, but hopefully it allows you to see trends a little bit easier in cases, or get a little bit more of a guess of what the asymptotic behavior might be for a given function. So now we'll look at multi-panel visualization. So we introduced this in, I believe, version 12 for the list plot family, list plot, list log plot, date list plot. And now in 13, we're expanding it out to a lot more functions. And the general mechanism is that you have plot layout, and you can say row or column, or give a list with row and how many rows you want, or column and how many columns you want. And it will create a panel like this, and all the scales are shared across all these plots. So all of the X ranges go from 0 to 100. All the Y ranges go from 0 to about 6, which is, in this case, determined by this panel as having the largest plot range. And so this has been expanded to plot and functions based on plot. So let's see if I can make that out a little bit bigger, and I shouldn't have done that because we get into a rendering bug now. But so anyway, plot, we can now do multiple plots at once. We can do density plots and contour plots. And I'm going to see if that fixes it. Okay. And so here we have 4 functions being fed into density plot, and we're doing a 2x2 grid of them. And you'll notice that this one is, has darker blues and brighter yellows than the other 3. And the reason for that is that, so all of these are, product of a cosine, product of a sine. You'd expect the magnitude to be roughly between -1 and 1. This one has a 3 out in front. So the magnitude, the plot range there goes from -3 to 3. And all of these plots are using the same scale for the color function. So the color function for all of them is scaled to go from -3 to 3, approximately. And so that's why this one has, the colors are a little bit different, is because it's the one that is making use of that full range of the color function. We can do stream plots and vector plots. So here we're doing a couple of stream plots, a couple of vector fields done as stream plots in a row layout. Introducing it for some of the charts, so bar chart and pie charts. In the case of those, they're going to use chart layout instead of plot layout. Just using the existing option names as appropriate for each function. We have histogram family of things. So histogram, smooth histogram. And here we're going to look at smooth histogram. I'm going to make this a little bit bigger. And so we have six data sets chosen from different Weibull distributions. And the X range in these cases is being determined sort of by the tail on this first one, which goes out the farthest. The others, the tail thins out farther to the left than the first one. And the height is coming from this last one because it's the tallest. And then in 13, we're also introducing multi-axis plots. So this allows you to, starting with list plot, list line plot, date list plots, to show multiple data sets in the same plot, but to have the data sets use different scales with different axes associated with them. So the aesthetics of this are still under flux a little bit, but here we have prime pi. So all the numbers less than all the primes, the number of primes less than a number, and Euler phi, which is the number of relatively primes less than a relatively prime numbers less than some number. And so the general growth trend on them is about the same, but the scales are different. So the blue curve, which is prime pi, has a blue axis on the left over here and goes from 0 to 25. Euler phi has a yellow axis and is going from 0 to 100. And I'll point out that sort of over here at the top, it looks like, okay, the curve for Euler phi is touching or maybe crossing the curve for prime pi. And in this case, that has no meaning because the axes are different and somewhat, how those line up doesn't have any meaning. So under a different scenario, perhaps you could have had the blue curve running through the middle of the yellow curve, and that wouldn't mean anything because you can't directly compare the curves and where they cross because they're on different scales. But you can compare what the growth patterns are. Are they going up at the same time? Are they going down at the same time? Do they have the same type of growth pattern? Are they doubling at the same rate? Types of things. And here we'll look at an example from finance. So we have three companies this time: Apple, Amazon, and Microsoft. And this time, instead of looking at the fractional change, we're looking at the actual closing price for each of those stocks. And so what happens is Amazon's stock price, when I looked at it earlier today, was about $3,200, give or take. Microsoft and Apple's are much lower. They've done various splits over the year to keep the per share price on their stocks lower. But it means that when we do a list plot of all three of these stocks, that Microsoft and Apple's behavior basically gets flattened out and you can't really see much about it. So we're going to use an option currently called multi-axis arrangement, although we haven't released 13 yet, and that's still subject to change. And what this is going to do is it's going to give each of these curves its own axis. And so we have three curves, we have three axes. We have a blue one, the yellow one, and the green one. And we'll see if I can get the tick labels for the blue one to show up. Small bug, development software, etc. And if I resize this, is that going to fix the rendering issue? Sort of? Okay. Actually, we'll just resize the window, which I think is the... Oh, if we take it full screen again. There we go. So in this case, what I've done is I've said that I want the first and third data sets to be on the left side, and I want the second one to be on the right. So Amazon's over here on the right, Apple and Microsoft are on the left now instead of, so we basically swapped this one and this one, the second and third. And we can also say, so I've added another level of list here, which then means that the first and third data set should share an axis. We're going to plot them on the same scale. And so here we have Apple in blue and Microsoft in green. And they're a little bit separated, but they're both using this axis on the left. And in this rendering, it's, that axis is partially green, partially blue. And it works reasonably well because they're relatively close, in terms of scale. I mean, there's maybe a factor of 2 difference between them, but it just means that you don't have all the lines drawing immediately on top of each other. So the last thing I want to mention for version 13 is that absolute options has been pretty completely overhauled. It should be much more reliable, much more useful for using it to inspect the properties of graphics. So here I have a scene that I constructed, and I have some okay, that's just my background rectangle. So I have rectangles that I've got a style applied to, and I'm just throwing transformations at it. It's rotated, rescaled, translated, and I threw a frame on for fun. And in the past, especially the translate, scale, rotate would have caused the absolute options to not know quite what to do. And so now in version 13, if we look at it, the plot range is minus 200 to 200 in about both directions. The aspect ratio is 1.02. The image padding, which is coming from these frame tick labels, is accurate. So 58 on the left and 13 on the right. Mostly coming from sort of that 200 that's poking past the edge of the graphic a little bit. 30 on the bottom and 6 on the top. 6 might be a little bit big, but it depends on, it knows what the style sheet is, and so that may be coming into play. If we look at the frame ticks, it knows that they're at minus 200, minus 180, 160, etc. These numbers are not quite what shows up there. Phooey, make a fool of me. Wonder why those are wrong. Something to look into. Whereas with, if we had did the same thing in version 12.3, it didn't know how to deal with the transforms, and it was like, and its fallback position in that case was, I'm just going to say the plot range is 0 to 1 in both directions. And as a consequence, the aspect ratio is 1. It had no concept of what the image padding was going to be, and just said it was all. And the frame ticks were sort of following its idea that the plot range was 0, 1, and so it just said that the ticks are 0 to 1 based things. It says that the style for the frame ticks was sort of pure black, which is not actually what the frame tick styling is by default. It's actually a gray level that's so it will show up, so the ticks will show up on a straight black background as opposed to just a white one. And so that covers what was new in 13. Quick glance over what was new in 12.2. So radial axis plot and parallel axis plot for visualizing high dimensional data. So if you have n-dimensional points, these are ways of showing those points in different axes at the same time. And we don't have enough time to get into them. Point value plot, which is sort of a very general type of visualization function that takes locations and annotations associated with the annotations and tries to map those annotations to meaningful and useful visual representations. So it will, depending on what the annotations look like and whether they're all different or there's a smaller number of values that are repeatedly reused, it will use colors coming from a gradient or colors coming from a fixed set of colors or size or shape. In this case, we have lists of numbers as our annotations, and it's creating little pie charts scattered at the various locations as the representation of what those pairs of numbers might mean or a way of interpreting them. Or you can manually say how you want the different annotations to be represented. And so in this case, we're saying that we have the same numbers as in this pie chart at the top, but instead of using a pie chart, we're going to use size and color to represent those annotations. And additionally, because it's the points, the location aspects of it can be geographic. And so I think this is the first function that we wrote in terms of plots that sort of spans being able to do geo and non-geo in the same function, depending on what the nature of the input was. And then array plot 3D as in the 3D extension of array plot. And that concludes what we have.